Yes, this is the presentation for the JMP usage in the Dmaic projects conducted at ST Microelectronics Malta. First of all, we heard about ST Microelectronics. It is a big manufacturer, main player in the semiconductor market. And yes, we are employing some 50,000 employees around the world. We are also servicing and supplying wafers and also packaged electronics to the major automotive suppliers and also to MEMS suppliers. And something a word about me. I am Carlo Zoppardi. I'm a Dmaic Black Belt, and I work by now for QMTR in the governance SPC group. And also I'm based in still Malta, in the island of Malta in Europe. So the agenda will be talking about the Dmaic Six Sigma program. Yes, for process and service, we are more concentrated obviously about process. Define stage, we go about the define stage, measure stage, analyze stage, improve stage, and control stage. And also we concentrate about the benefit of using JMP in these stages and what are the most important and most utilized sections of JMP that we use in our work. This is an example, a very short example and summarized example of a Dmaic that we would do at ST Malta. It gives you just a hint of what is each stage. Important is to define the problem, to know the voice of the customer, and also to do the project charter, where we see that we do a definition of what we're going to do, a SMART objective, okay? It has to be specific, measurable, achievable. It must be you must be responsible for it. It must refer to you, and also it must be time-based. And then there is a performance measure, okay, and where we do the process performance, we do the capability studies, we do the MSA majorly, and then we also got the analyze phase where we analyze actions that we want to do. We do the classical Ishikawa diagram, we compare, we do tests, and we see what we can act upon. Then we do the group these actions in the improve phase, basically in the DOE, and we analyze it statistically. And also then we run again at control long runs to confirm what was on the DOE is working over time and on high production. Finally, we check that these savings that we have acted for, the reduction in defects, have been concretely done. So define stage is basically the project charter and smart objectives, and we're going to use time series plots, chart builder, and Pareto chart. So the use of the time series plot is very important in the define stage. We want to see what is our baseline, how we are doing by now, what is our entitlement, what the best that we have ever done, and we have to reach down 70% down the way to the best entitlement to reach our target. This is the classical Six Sigma approach, okay, to Dmaic. And we establish these targets and we work towards them. Visually, the chart builder gives us the benefit to give a good impression of what we're doing by now, and also on months or weeks, we can see the performance. The Pareto chart, the classical Pareto chart, can be used both to give a reason why we chose this project, number one, and also later on to find the major defects that we want to work upon. It gives us the 80% versus 20%, the trivial many versus the most important few, okay? And we work upon the most important few so that we, so that we do get the result. So this is quite used in this part of the Dmaic, and then we go to the measure stage. The measure stage, basically, we have to do the MSA, which concludes the linearity and bias, the stability check, and also the GRR, and also the capability of the line, the process. What is the capability? Where we are by now. And first of all, a good tool is to use the goodness of fit. So as using the goodness of fit, we'll know what kind of distribution of data we've got, so that when we apply the capability tests, we know which kind of distributions we want to use in our work. The other thing is that we have to start to do SPC charts. From the SPC chart, we see the trend of our data. We see also locations of out of control. We can, in JMP, use the particular control limits that we need for our process, and also do establish rules to find the out of controls and work upon them. Secondly, we record the capability from this sampling subgroup size that we have chosen, and also the capability, and then we can work upon it later on to optimize it. The process capability is basically we put the lower spec limit and the upper spec limit. We know the distribution of the data, and we're going to establish the PPK and CPK for our process. And also over here, we record it and we use the distribution that most fits our data. The measurement, here we see an example of linearity and bias. It also helps us analytically, statistically to see that the bias is on average, the average of the bias is 0, okay? And also that we have a slope, which is hypothesis on the slope, which gives us a slope also of 0, that basically is flat along the tolerance of our parts, and basically we have a good bias which is stable along the tolerance. If we look at the JMP usage in GRR, here we see an example of two measuring systems being compared, and looking at the data, you will see that for the same parts, immediately you can see that one measuring machine, is giving us more variance than the other machine. So we can compare, we can use different aspects of the data, and also, for example, the AIAG criteria. We can compare it, and we get the result and see how these machines and also maybe operators compare in their work. Analyze stage. The analyze stage is basically very important. We're going to start from the beginning. We're going to draft a fishbone diagram, a Ishikawa diagram, which is the basis of our analysis. We're going to do sampling plans to see how economically you can face the problem, and also, yes, hypothesis tests for our tests to see that they are significant statistically, and later on we decide engineering-wise and management-wise whether they make sense or not. So basically, this is a fishbone diagram for one of our processes. You can see that you can branch, okay? So we use the parent and child option of the fishbone diagram, and we get this kind of fishbone diagram that we can work upon to find later on through a cause-effect matrix the most important causes towards an effect. Sampling size is very important to understand that with our alpha and beta that we choose, we've got also an acceptance quality limit and the rejection quality limit, and we get an economical sample on which, if we take that sample and we do our tests upon it, we can envisage what will happen on the population or on the large runs, okay? So basically we can have a good understanding of how much probability we've got to meet the target that we are hunting, basically. Effects and process and service changes. So basically, when we do service changes to your process, you want to understand whether the variance is changing in your tests, and also whether how it is saturating or not, or whether you reach a peak or not. And this you can do with the XY charter, okay? You can see here that we check for variance, and we check also for the averages, that they are equal or not. The averages are not equal, and in this case, the variance is for that we're equal. So basically here, we're changing, for example, the temperature in an experiment, we're checking the adhesion, and we'll see that it saturates above 180 degrees Celsius, okay? So basically, it gives us a good indication also visually that we have the same variance along the way, but we have a step increase, okay? We slope up, and then we saturate at a particular level. We move to improved stage. The improved stage, classically the DOE, design of experiment. At ST, we target to use CCD designs. We also, depending on the economical constraints, and also we have an use RSM, response surface designs. So basically, I can show you some examples. So we have a cyclical community too, and we teach our engineers how to plan a DOE, do the proper plan, execute it, analyze it, do the replicates, do the F test for the yes, for the for the lack of fit, and check the residuals, do the whole work of the statistics to a high level. We have a standardized report, and this report is done all over the plants. To say the truth, we take also we have a community which we work upon, and we teach the other also plants how to do the OEs and also work on their problems too. So basically, you can see here that you got all the tools that one needs for statistical analysis of the design of experiment. From it, later on, we see the profiler. We can do also process space, where we see how variance in our inputs will affect the output. Here's the profiler. We're gonna optimize at a particular level. There are some tricks also that you have to understand that, for example, if you are reducing a particular response, it must not go down completely minimize, but target a lower level. And you can see that you can have the optimal parameters for each for each factor, whether they are stable, whether they're robust, whether they are affecting much, whether they're not affecting much. You have, for example, in this case, the board type was a block. Okay, it was you have to choose one of them. For example, here F20 and F40 would have given a good result. F30 is low. So basically, you have to understand well the DOE criteria. You have to know your process, ideally, okay, or get a person who's doing the DOE to give you an understanding of the process, an understanding of statistics, and together you do one team. Control stage. The control stage is basically you're going to actuate what you have come out from the DOE, and you do on a analytical way on a time scale. And in that case, you have to do for sure control charts. You have to see before and after. You have to see that your control limits are doing tighter, that you are well inside your specifications, and in the end, that we will see later that your CPK and PPK are better. That means you have moved towards a better status. And also the classical painter chart. The painter chart is something that you put available to all management and to all employees, whereby you do the actions and you put a target, which is a good visual aid, okay, where you work upon it, and this way you see that your actions are in fact working, and also you can see which actions were most important, because you see a dip in the, for example, in the yield loss, which towards your target and even under the target that you had set up. So basically, that is all from our side. And yes, we are using JMP both for statistical analysis, and also we are integrating it inside our Dmaic methodology to both to visualize data and also to analyze statistically our actions and our runs, basically. Thank you.